Electronics and Communication and MTech in Microelectronics from Rajendra Technical. He has worked in industries like integrated microsystem on quantum mechanical software from Synopsys Technical Specialist for 8 years. He has provided training on nanotechnical simulation software like quantum mechanics in various renowned institutes. His current company, Impulse Technology, is currently working on nano academics software suite Nano Decal. So with this brief introduction, now I would like to request Mr. Sharma to kindly take over from here. Over to you, sir.
So thank you very much for the great invitations that you have invited us as a speaker. So it's a very pleasure to invite us in this great webinar, great workshop, INUP. And I would like to thank Dr. Arun Tej, Dr. Dipankar Bandyopadhyay, Dr. Akshay Kumar, and all the supporting team members who annually or quarterly organize such a great webinar for this great events. So today we will discuss about how the different kind of simulation software that can help you to boost your research in the domain of optoelectronics device applications. So since the aim of this workshop is just to make familiarized with the open source as well as commercial softwares. So how the open source and commercial software can benefit you in your research in this particular domains. Either it is optoelectronics, solar cells, OLED, large area or PV module kind of applications. Maybe you have attended Escape's Bandit webinar or maybe in the tomorrow you will attend it. Similarly, we have this LAOSS softwares. So the presentation will be done in a first session, then we'll also deliver the live demo that how it can be done in your particular computer. Since around 50 license is already given the permission to the department, and even more prospects will be interested deeply in our tool, then we can have a one-to-one discussion and we can provide you a 1 month trial versions of the commercial softwares. So let's get started. So I would like to introduce about our company that is called Impulse Technology. This Impulse Technology, it is our company. We are located in Delhi near about Gurgaon, and we have a different partners, channel partner. The one partner is called Fluxim. The Fluxim is basically a Switzerland-based company which provide the simulation tool as well as some equipment for the characterizations related to the optoelectronics domains. So either you want to simulate the solar cells, LEDs, batteries, PV modules, or other optoelectronics related applications, including the perovskite applications, tandem applications, pixel crosstalk applications, and many more in this optoelectronics domains. So virtual simulation in the software as well as the characterization by using the equipment. I will go to in the detail in the coming slides. Apart from that, those who work on atomic scale modeling, that DFT calculations, nano material, nano device calculation, we have a nano academic technology partner that provide atomistics, nanoscale, crystal material and device simulation while using density functional theory and perturbation with quantum transports calculations. So at micro level, this Fluxim is one of the partner where you can simulate micro level device structures, including the array and PV modules applications. For atomic based material and device simulation, we have this nano academic technology. Today we will focus about this Fluxim only. So I want to introduce about our parent company, that's name called Fluxim. Flux, that stands from Flux. So Fluxim is basically a Switzerland based company which provide the software for simulation as well as hardware, where you can also characterize some different properties of your devices. I will tell you how. So this is basically provide the software and hardware for R&D industries all over worldwide. Those who works on OLED, display, lighting, solar cells in industry as well as academic institute, both. So the company was started from Zurich University of Applied Science in 2006. So around 17-18 years of development in this particular optoelectronics research. If we talk about the software for the simulation purpose, that is called SAT-FOSS and LAOSS. You can see these are SAT-FOSS and LAOSS. These are two products. One is called SAT-FOSS, that is a competitor of Escapes Bundy, but more advanced features as compared to the Escapes Bundy, because it can perform unlimited number of semiconducting device simulations. So for one-dimensional simulation, this allows this SAT-FOSS product is there, which can simulate the perovskite, tandem, thin film, or organic solar cells application at micro level, one-dimensional structures for incoupling, outcoupling, and light absorbing applications for optoelectronics calculations, optical analysis, and electrical analysis. If somebody want to work on large area devices where there are the thickness of the device solar cell is in millimeter or micrometers in higher range side, then this LAOSS product will be very helpful for large area organic semiconductor device application. And what are the problems that will be overcome by using LAOSS? That coming through the SAT-FOSS or Escapes Bundy, because Escapes Bundy and SAT-FOSS both are one-dimensional simulation software at a cell level, not at micro level or large area devices. At particular cell level simulation, Escapes Bundy or SAT-FOSS is more good enough. But when you go in the advanced levels for large area where the size of your device increases, then you require some more tool which can handle the complex geometry of your device structure, of your electrode structures, or the losses, whatever happening in your device, that should be overcome. That's why this LAOSS software will come in the picture, where large area devices simulated and the losses will be there in one-dimensional tool that can overcome by using this LAOSS softwares. So this is this brief idea about SAT-FOSS and LAOSS. We'll go to the detail in one by one. And since the company not only developed the software, because software is based on theoretical predictions on the basis of model equations, parameters, it will solve the equations based on theoretical assumptions and it will plot the near to the experimental characteristics. So that before going to the experimental in the lab or going to the fabricate your device, synthesize your material, you can virtually simulate your material behavior, material characteristics, and then you can go for the final experiments. So we have also supplied this hardware. You can see in the red color, PIOS, pillows, LAOSS light. These are basically a equipment where you can characterize your solar cell electrical and optical characteristics. Let's suppose you have a sample of solar cells, and that sample of solar cell you want to study what will be the current voltage characteristics, what will be the LED cases, electroluminance, photoluminance, spectra. So for electrical characterizations, impedance measurements, transient measurements, characteristics, then this PIOS is useful. And for electroluminance, photoluminance, goniometer, then this LAOSS is useful. For stability analysis of your solar cells, let's suppose you want to study the perovskite solar cell degradation analysis or how much the solar cell is stable, then this LAOSS light are very helpful, where you can also measure your characteristics of your device applications. So these are equipment where the electrical optical emission property can be measured on the experimental levels, and it can also match with the theoretical simulations. So software and equipment both are aligned to each other so that you can find either you can go directly with the equipment for the characterize your device application, or you can perform your virtual simulation by using the software, and then based on the final your accurate input characteristics you can fabricate your device. So these are all single all-in-one measurement platform with integrated analysis software for electrical optical device characterization, parameter extraction, and model, whatever model you have applied, you can also validate by using the product that Fluxin supply. Now, if we talk about this, since you are will also attend or maybe attended Escapes Bundy. Escapes Bundy is also a very good tool for open source simulation, where this kind of commercial tools are not available in the educational institute. Then Escapes Bundy is good. But as compared to the Escapes Bundy, we have this SatFOSS software for one-dimensional simulations, where perovskite, tandem, thin film, organic, similar functionality as compared to Escapes with advanced advantages as well. In terms of number of semiconducting layers, unlimited semiconducting layers at cell level, it can be simulated by using this SatFOSS. Multiple parallel transient simulations, LED simulations, emission calculations, and with different state of art mobility models are implemented, and some ion transport models are included, including with the charge transports as well. So charge transport with ion transport, anion and cations, but will not be there in Escapes Bundy. Transient will not be there with Escapes Bundy, and unlimited number of semiconducting layer. Let's suppose you want to simulate a 10 layer, 20 layer, or tandem solar cell where there are so many layers. Then Escapes may be able to not simulate more than 7 layers. That's why this SatFOSS can be helpful in this particular cell one-dimensional applications. So this is brief idea about SatFOSS also. Since this webinar was totally focused on LAOSS, then so we will discuss about this LAOSS software. LAOSS is basically if you want to simulate the device where the area of the device is bigger, okay, and in your small devices there are losses are happening, but it could be a temperature losses where you are applying some temperature on your device. It may be get heated or overheated, so that kind of losses can be overcome, or some electrical losses may be there. The losses may be due to the geometry of your electrode, wherever you will apply some biasing on the terminal. Suppose you have a solar cell, P and junction is there, and you fall some spectrum, light spectrum, EM0, EM1.5, or whatever the spectrum you fall. And whenever you are measuring its characteristics, there may be some losses are there. It could be the electrical losses, it could be the thermal losses, heating, or optical losses. So in this case, and for crosstalk applications, pixel, crosstalk, AM, OLED, in nowadays in you may be heard about active matrix, organic light emitting diode, or quantum LEDs. So this software can help you to simulate the crosstalk, array, RGB, or some large area PV modules. Multiple cells can be connected together and you can simulate its behavior. So this software is to design and optimize the large area devices. It is based on two-dimensional model plus one-dimensional model. Two-dimensional where there is FEM is there, finite element method option is there. You can generate your mesh, triangular, hexagonal mesh can be generated, and you can optimize your device structure based on different certain input parameters. Input parameter in the sense, whenever you simulate your device, you may have some different thickness, maybe different doping concentrations, or maybe some different work functions, or maybe a couple of other input parameters. So you can optimize your devices and you can simulate it. And the losses are happening in your device. It could be by overheating of your device. That overheating can be overcome by using thermal module. Electrical module is there where you can simulate the characteristics of large area device, optimize your electrode design. The electrode design may having pentagonal of mesh size, hexagonal type of mesh size, or maybe some different geometry. Ultimately, due to the geometry problem, some losses also happen. And how we can optimize the more greater accuracy, to increase the greater accuracy to optimize your device structures. Optimization is very important so that you will reach at your final approximations output. So that's why this electrical module is there. So software is divided in module, electrical module, thermal module, optical module, whatever module convenient for you, that can be planned. So basically for reduction of electrical losses, non-ideal effect, maybe in LEDs or solar cell, maybe some unknown things may be there, which is affecting your device efficiency. So this software will try to more to get it converge quickly, and it will try to produce more accurate characteristics of your device based on theoretical assumptions. It will understand the electrical crosstalk in RGB OLED pixel array. Multiple arrays can be created and you can get it simulated. And thermal module, which can also coupled with electrical. So electrical module, thermal module, both can be independently, it can work, or it can be connected together, so that simultaneously you can overcome the electrical losses as well as the thermal losses. So this thermal module, that is a two-way interaction between the heat generation and electrical properties of semiconducting devices. It will calculate the temperature distribution. Whenever you apply some temperature in your device, the distribution will be happen. It can measure or calculate the temperature distribution in your solar cell or OLED with different standard conditions. And it will also explain the non-ideal IV characteristics, whatever due to the electrothermal coupling or any other regions. So that's why electrical losses, thermal losses or electrothermal losses can also be overcome, including independent optical module is there. So this optical module where it contains the powerful 3D ray tracing module, where whenever the rays are entering on the device, it will capture the device how the rays are diffracting or refracting, or how much the light get absorbed by your device. So that optical analysis or remove some optical losses, that can also be overcome by using this optical module. So software is divided in module, whatever the module, maybe you are working on only electrical part initially, only electrical with the thermal as well, or all of them together can also be taken. Now you can see this is a standalone 3D optical element with their contribution of the device. It can also help to simulate the optical crosstalk in OLED display. It can be coupled with the SATFOS to analyze OLED and PV with complex light outcoupling geometry. So this LAOSS is two-dimensional large area device simulation software. If you already have the results from one-dimensional tool, or let's suppose you have a IV characteristics from other source, that IV characteristic data you can upload, you can import in this LAOSS as well. So that's why it is telling the SATFOS results can also be imported. Even in other third-party output, let's suppose you have a current voltage characteristics you want to upload and you want to compare with your one-dimensional or any other tool with this LAOSS for large area device application tool. So that's why this software is divided, and it's a brief idea about the LAOSS. Now let me discuss about each module. As I told you, there are three modules: electrical module, thermal module, and optical module. So this electrical module is basically a 2D FEM finite element based module, which will solve the Ohm's law in two-dimensional in two electrodes, top and bottom electrodes, and it can also coupled means it can integrate with one-dimensional Scarps Bundy or SATFOS tools. So 2D plus Bundy FEM simulation, that's why we have called in the beginning. SATFOS was only for one-dimensional. This software for two-dimensional plus one-dimensional, which can solve the Ohm's law in two electrodes. Now this LAOSS simulation with electrical module can use to optimize the geometry. Either you are working on emissive devices or optical devices without costly or time-consuming process of device fabrications. Sometimes what happen, the geometry which you created on top of the surface, and that geometry may get your light back in the environment. So that's why this software can help you to judge, to understand that how much light get absorbed by your device by using this module, and you can find the electrical characteristics. Now you can see This is a reduction of electrical losses. So optimization of device electrode in OLED or PB, potential distributions at top electrode that can be optimized with the distinct metal finger grid. Metal finger grid can be created on top of the solar cell. I will show you in the coming picture. You can simulate the light LED lighting panel or large area devices. As you can see, this is a 2D FEM based device structure where you can define some cathodes, boundary conditions, bond decoupling, loss are there, input quantity, and you can calculate the current density potentials. So anode boundary conditions, some cathode boundary conditions, you can define and integrate 2D plus Bundy FEM simulation and find the current density potentials. You can see this is electrical potential, which you can see in the screen, and IV characteristics. So this is some characteristics channel visualization data which you can visualize once you find some losses, electrical losses or different losses in one dimensional as well as in the graphical representations. Now in this same electrical module, if you want to optimize your device, metal finger grid option is there. So you can create multiple metal finger. Metal finger in the sense there is some strip line on your solar cells are there. That strip line geometry can be created in the tool and it can also get it optimized. So that's why this metal kind of finger grid can be created or added to the transparent electrode of this photovoltaic device that will help to improve the conductivity or device efficiency. In coming slide, I will show you how the metal finger or different kind of grids can be created on top of the solar cell structures. So you can choose the different material, whatever the material you want to use for the metallic or even for the semiconducting layers. So there are two major important parameters for this to choose the type of electrode with respect to its transparency and conductivity. So we can easily select whatever the parameter, whatever the material, and LAOSS can also use to produce a chart of best materials for photovoltaic depend on device size. So you can optimize with minimum value, maximum value, and run the job. You can set the minimum parameter of particular value, let's suppose temperature, potential, thickness, or whatever the current it is there. Minimum and maxima it can set, and you can run the job. It will plot the characteristics on each and every point voltage or whatever the input you have given. Now you can see this is a maximum output power watt per meter square, and with respect to metal finger width grid. So losses are happening due to low global conductivity. Metal finger optimal bits power are there, and in this particular region why the losses are there. So losses are there due to low global conductivity and loss due to shadowing of the effect. So that's why this potential graphical representation can be visualized, and it will help you to optimize or to maximize your output. And accordingly, the sample 1 and sample 2, there are two samples taken. Sample 1 red graph and sample 2 blue graph. And accordingly, this electrode side length of the electrode is taken in centimeter, 0, 2 centimeter, 4 centimeter, 6 centimeter, 8 centimeter or 10 centimeter. And maximum output power. This is maximum output power that can be calculated. Accordingly, you can judge that how much light that reduction in the losses is happened. Now, if we talk about some different more models are there. So there is some non-ideal effect models are there for solar cell and LED both application. So this electrical shunts are there, which are unwanted short circuit that can be happened by this non-ideal effect that between the two metallic electrode, and that will decrease the efficiency of the device. So unwanted short circuit are happening, that electrical losses are happening due to not unwanted short circuit of the device structures. So that non-ideal effect can also be overcome. This LAOSS can also simulate the distribution of your potential and current inside the whole device. At what particular regions you are getting the maximum current, or which particular region you are getting the less currents. So this kind of things can be done, and this result can be correlated. Non-uniformity of device can be simulated, and now you can see in this picture, understanding electrical crosstalk in RGB OLED pixel array. So this pixel in OLED display can be electrically coupled to the electrical lateral leakage current of common layer, or that will call, this effect will call the cross strike. Okay. So adjacent pixel in OLED display that can electrically coupled through the lateral leakage current of a common layer. That is called, this effect is called the crosstalk, and results in unwanted light emitting from the unaddressed pixel of different colors. You can see this one, this image, where red, green and blue, these are three different colors are there, and these are some different pixels. The square pixels are there. So this effect, this pixel which is having the different colors, and that will reduce the constant ratio, and that can determine the color gamut of the device. So LAOSS can achieve the quantitative understanding of electrical crosstalk in OLED. So let's suppose you can see this RGB pixel array device structures, and in this pixel device structure can be created in this LAOSS. You can create the geometry in rectangular or different other shapes are there, and find this array can be created, and once you will simulate this device structure, crosstalk currents can be generated, and you can find the potential and other characteristics. In the demo part, I will open the software, and in the software as well, I will show you live. And after this presentation demonstration, those who is having the license of this LAOSS, because 50 license is given to the institute, and you can also explore it. If you have any problem during the exploration, you can let us know. We can also help you technically. Now, whatever the results are coming by the virtual simulation through the LAOSS, are they validated? Are the results are reliable? So that's why we provide the reliable characteristics of your device structures. So this LAOSS can do the simulation successfully on different experiments we have tested. So you can see this is one paper where inhomogeneous luminance in organic LED related to electrode resistivity that has been reproduced. So luminance is calculated. You can see this experimental red graph and blue graph from this particular 0 to 15. You can see this LAOSS results, and this is experimental result, red one. So around 95, 96, 98, 92% accuracy we can predict based on theoretical models, and then you can go for the fabrication for the characterize based on your final material input parameters. That can save your time, that can save your money, and that can save your that different iterations that you will going to perform on your materials. So the material or device, it could be wasted if you are not getting the reliable results. So that's why this simulation tool will help you to understand as a theoretical aspect how the behavior of the device will be changed on different, in which different conditions. Now I have explained about the thermal module. Sorry, I have explained about the electrical module. If we talk about the thermal module for heating or temperature analysis, then this thermal module is there. So this thermal module can also be integrated with the electrical module, so that electrothermal module property can be calculated. So electrothermal coupling, which will help you to simulate the two-way interaction between the heat generation and the current flow. It will calculate the temperature distribution in your whole device. Let's suppose you have a sample of the solar cell. You applied some biasing on the electrode contact, and due to the current will flow inside the device, and whatever the potential temperature distribution in your device, that study can also be understood. So in this different scenario, the current flowing inside the solar cell or OLED, that will heat up the device because of Joule heating. LAOSS can calculate the position dependent temperature in the device and correlated potential with different distribution of temperature. Heat generation and current flow in two-way interaction, that can also be simulated. Non-ideal IV characteristics in OLED and solar cell. In this two-way electrothermal coupling, heat is generated due to the current flow, the electrical conductivity inside the semiconductor stack, that will increase the rising temperature. Now with this two-way electrothermal model, this LAOSS can calculate the temperature distribution operating and different shape, either it could be S shape or L shape, whatever the shape, characteristics, IV characteristics, positive feedback from increasing temperature, increasing current, increasing temperature, that kind of study. Current density, that can increase when you applied voltage decreases because the temperature increases at the same time. You can see this is some finger grid geometry that has created, and this is a hexagonal type of metal finger grid which is created in the geometry builder and imported in the tool, and then applied some different model input parameter and do the simulation and plot some characteristics based on different voltage wise. The current density is plotted on different valence band gap of the materials. So that's why this is two graphs that will represent for thermal module heating related characteristics. Now the third module is called optical module, that is basically for ray tracing analysis, that will help to simulate the 3D optical element. So this module is basically the light incoupling and light outcoupling in solar cell and LED that can functionalize by complex 3D optical element or the surface texturing. Because the ray tracing module is there, this ray tracing module can be very helpful for surface texturing, where the planar surface is not there. There is some irregular shape, some different complicated structures are there. So that's why the texturing of the device, where different geometry can be textured by top or bottom of the electrodes. So this 3D optical element, Fresnel lens or other optical element, that can also be coupled with LED solar cell to improve the efficiency. Device surface in effective solution with device light outcoupling. LAOSS can also model the optical output of fusion optical element with a powerful ray tracing algorithm, and it can also be integrated with SATFOS for light outcoupling geometry. Optical crosstalk optical analysis for the crosstalk LED application, it is helpful. For optical crosstalk in given by the light, and that is scattered inside the optical and leak the new pixel before the final release. So WOLED or AM OLED active matrix or different RGB pixel crosstalk or all the geometrical complex geometry can be simulated. You can see the LAOSS can capture the nature of pixel crosstalk, and that simulation suitable tool to optimize the characteristics of pixel matrix without costly or time consuming fabrication or testing process. That's why this virtual analysis will be there, and based on theoretical model parameter validation, you can predict your device characteristics. This is some different device, WOLED or some different planes. It is simulated and it will be plotted. In this optical analysis, since it is for ray tracing analysis, so either you want to simulate the curved shape liquid crystal related display application, AMOLED, LCD application, or pixel array application. It can be helpful for spatial or angular uniformity or luminance. This is also helpful for flexible thin film lightweight application, edge lighting. As you can see in the cell phone, due to the edge of the surface of the cell phone, there is some different effect maybe there. Some car automotive car designings are there, quantum LEDs are there. So in this particular scenario, this tool will be very helpful to optimize the particular shape of your solar cell application. And by using this ray tracing analysis, you can see how much the light will get absorbed or refract and diffuse in your device. Now in this LAOSS, there are a couple of examples are there. Examples like AMOLED, active matrix, organic light emitting crosstalk. Example is already given to the beginner, how the beginner will start learning on the tool. AMOLED with crosstalk and different sections. Section in the sense the different segment. Z segment will be there. So the segment related active matrix OLED, basic OLED simulation without thermal effect, with thermal effect, OPB module, full module simulation where multiple cells are connected in the series, hexagonal type of metal geometry, finger grid, pixel crosstalk array, metal grid simulation. Participants, I request you kindly mute your mic. Metal grid with bits optimization of your device, series interconnected cells, solar concentrator, or uniformity optimization, plain rectangular OLED, and so many more examples are there, or user can create different kind of other example in the tool. This software support on Windows, Linux, 10, 8, Ubuntu, CentOS. So basically i5 or i7 processor is good enough. With 8 GB also sufficient to run the calculation. If more is better, more hardware configuration is there in your computer, then definitely you will get a faster simulation speed. Multiple parallel processing on different cores. So job threadings are there, multiple processings can be simulated for different devices. You can also get 1 month trial version of the SetFOSS or LAOSS, whatever the tool convenient for you. Trial version can be provided so that you can see how this tool can be benefit. So before going to the trial version, you need to understand either this tool is really helpful in your particular domain, whatever you are working on. So accordingly, you can judge and let us know. We have so many YouTube videos are there. So you can visit our channel Fluxim or Impulse Technology, where a couple of videos on Fluxim website is also available. So that will help you to understand quickly for the new beginners. So scientific videos library, publication papers, manual, tutorial, example, and technical support in persons. In an online mode, we can also help you so that you will find, yes, this kind of product can help to boost your research in this particular optoelectronics domains. There are a couple of LAOSS tutorial are there already inbuilt with the software. Whenever you will install the software, you will find a list of tutorials that one by one, once you will follow it, you can also create different project by yourself. With all the manuals are there, numerical physical model implemented in the tool. In English, all are well explained with the example and online technical support that can also be provided by telecalling, by WhatsApp, by Google Meet. We usually available online so that user will satisfy before going to plan in the future. Even IIT Guwahati is already procured this LAOSS softwares. So this was basically an overview of LAOSS tool. what this tool will do, what kind of modules it consists, and what are the modules are divided, what will be the role of electrical module, thermal module, or optical module. Now, as I told in the presentation beginning, the set force is for one dimensional, LAOSS is for large area, crosstalk, PV module, and array simulation. This is one equipment. In the beginning, second slide, I inform about BIOS, that is for electrical optical characterization and impedance measurement with transients. For ELPL measurement, electroluminance, photoluminance, flows is there. For LAOSS for stability of OLED and LAOSS light for stability analysis of solar cell applications. So this is all about scientific product that our company is representing in India and supplying in India as well. For atomic scale modeling, nanomaterial, crystal, molecule, nano device simulation at atom-based device structure simulation, then we have this nano decal with their advanced version, rescue and their advanced version, the QTCAT for quantum confinement, quantum technology, spin qubit device application, QTCAT tools are there. So you can judge which domain is more expertise you can gain in this particular domain. Accordingly, we can suggest you the better tool which will help to boost in your careers. So for atomic scale, nano decal and rescue are there. For quantum technology, qubit application, QTCAT tool are there. So this is all about brief presentation. If any participants will have any technical query or today or maybe after this webinar, you can note down my contact number. This is my contact information. So you can call me, email me. I can help you or reply in your email communications. This is my contact information. So thank you very much for giving your patience and listening the presentation session carefully. Sorry. Now I will go to the thank you page. So thank you very much. We'll go for the live session on the demo part where I will interact you with the tool, with the software, how it look like,